Okay. For this year, and the bitch, so there probably wasn't enough room to accommodate.
Hey, Steve, I think we need to mute everybody.
Yes, I will do that. They're gonna have 3 kids each, although they don't get vacation, they'll get the remainder of their blue days. After they're done their,
So it's 5 years, you bump up to 3, and then at 10 years?
10 to 4.
Oh, okay.
There we go. All right. Rick, you're muted. Can you unmute and I'll make you the host, buddy?
Okay, Steve, I'm unmuted. I don't know about Rick.
Yep,
there.
you're unmuted
There he
now.
is.
Tell you
Hey,
what,
Rick.
sorry, I'm still getting my head wrapped around this thing. So,
I'm gonna make you the host, Ricky.
okay, I was wondering because, like I said, I thought you had to start and had to leave early or something.
Yeah, sorry, that was my bad. I had got a work commitment that I couldn't get out of, so I'm going to have to make you the host, buddy. And unfortunately, Jerry, I have to back out, but I think maybe give it a few minutes, more guys will join.
Okay. Yep, we'll do.
Okay, thanks, guys. Sorry about that.
So what's going on good in Canada these days?
Well, not much. I know probably about 4 hours north of 6 hours north of me is 40 centimeters of snow coming down in Kenora, but beyond that, we're still whatever. I guess 50 degrees and sunny. So,
Hey, good for you.
we'll take a few more days of it. I think we got rain and then wet snow coming or something.
Yeah, yeah. Now you guys are in Ontario, right?
Correct, sir.
Uh-huh.
Yep.
Uh-huh.
I go
Oh,
5
cool.
hours north. I'm working in Sudbury for the next 2 weeks, teaching up at the Sudbury Fire Department, and I think they're calling for wet snow at the tail end of next week. So
Oh,
we'll go through some culture shock, I think.
Are you retired, Rick, or what do you do?
Yeah, I pulled the plug. I guess coming up 6 years ago now. Seems like yesterday, but yeah, after 30 years in with Toronto, a couple of years of volunteer, I gave it up in January 2016. So.
Good for you.
So yeah, so did Mr. Knighton up there in the top corner. He pulled plug too. So good man. I think you're living on farm country somewhere east, aren't you? Yeah, you're still
Mike,
muted, Mike. So
you got to unmute.
Yeah,
There you go.
I'm just north of Brockville.
good. I'll be going through there. I think in April. I got to head out to Nova Scotia. So
Wow.
I'll do that lovely Kiwi.
Stop by.
Well, I'll have to give it some thought. I'm planning to try and make it a couple of stops along the way because I'm not doing the power drive. So.
Yeah.
So yeah. So how long are you today, Jerry? What are you figuring?
All right, we'll do like 20 minutes and then open it up for questions,
Okay.
discussion. If that's all right. We're just going to talk about procedures and SOPs and stuff and get that knocked out. I think I got one scenario in there, underground gas leak, so we can do that. So Rick, I'm ready if you are. If you think,
Yeah, I'm going to say go ahead because again, I'm not sure if Steve had much in terms of what numbers and stuff. So yeah,
Okay.
if we go ahead, we'll welcome everybody into the group and give it to you, Jerry, to talk.
Okay, well, here we go. We're going to talk about procedures for natural gas emergencies today. I'm going to try to get my slides up here. Host disabled participant screen sharing. So Rick, if you can allow me to show share my screen, that'd be great. And I'm not really sure how to do that.
Yeah, I'm there too because what have I got going here? Let me see. One participant be sure at a time, multiple participants. So let's do that one and see. Did that open a door for you at all?
Yes, it did. So here we go. We just got a few slides. Okay, you guys should be seeing my slides, correct? Oops,
We are, sir. Yep, you're still in kind of the work format, not on the big
There
show
we go.
yet.
So I don't know if Dan Moreno's on. He said he was going to be. I didn't see his name there, but he's my co-conspirator. So we just want to give a little shout out to him. So we're going to talk about procedures. So just a quick review of what the problem is in responding to natural gas emergencies. Our training is generally weak. Some departments are better than others. Some utilities are better than others. our SOPs are generally weak, and that's kind of what we're going to talk about today. And they should be similar to gas industry best practices. And then we talked, you guys are in the hazmat world are probably pretty good with your air monitoring, but most fire departments in the US are pretty terrible at it. Again, it's just not in any of our curriculums at the level it needs to be. So the result is on a scene, we end up making up procedures. The officer in charge kind of, does the procedures based on what he thinks is right and based on his experience and his lack of or his amount of training. So that's kind of the problem. We don't want to do that. So again, we're going to talk about two things today: size up and then our response procedures. So this is Dan Moran's vacation house.
Like it?
Yeah. So actually, I was doing this for I won't tell you where, a fire department somewhere down by me here, and they all started laughing. I'm like, well, yeah, it's funny, and they're like, no, you don't get it. And they're like, wait till you go in the kitchen. So they had done this in their kitchen as well. So they had their grill. But anyway, we're talking about natural gas and propane. This is Farmington, Maine. This was a line of duty death. I talked about this last time. So what we talk about today is generally applicable to natural gas and propane. Obviously, natural gas is lighter than air, propane's heavier, and flammable ranges are a little different. So we're basically the same. I wanted to throw this in. I don't know if you guys are seeing this. We are seeing a lot of it. Instead of the old-fashioned black rigid pipe, we call it black pipe. We're seeing CSST, corrugated stainless steel tubing, replace that. The upper version is the non-grounded type that needs to be grounded, by the way. And the lower version there has a metal mesh screen that actually is the ground. And I think I have a picture. The problem is if there's a lightning strike in the area or there's a short in the electrical system, if this system gets energized, it arcs, creates a hole, creates a gas leak, creates a fire. There was actually Lieutenant Nathan Flynn in Maryland was killed at a fire that started like this from the CSST. So Rick, are you guys seeing this up your way?
I've just seen a lot of the yellow aspect up there in terms of a lot of the flex lines, a lot of stuff running outside the house. So yeah, I think it's perhaps familiar to most of our guys.
Okay, so just keep an eye out. There's some good information on the web about it. This is a condo complex in let's see, Pennsylvania. Yeah, if you see the arrow in the upper left there, there's just bundles of this stuff. So you can imagine, maybe snow comes off the roof and damages this, or kids are in there climbing around or whatever. So just kind of something to keep in mind. It's obviously a lot cheaper and faster to put in. It just bends. You don't have to thread pipe and do elbows and that kind of thing. And here's this was, I forgot where this fire was, but this actually, this was a test. This was they were testing this stuff, and actually when it arcs, it just creates a hole in itself, and obviously leads to a gas leak. So here's the 6 types of gas leaks. We're going to talk about number 4 today: the outside odor of gas or underground leak, and then we'll get into that just at the very end. So we said you should have a procedure-based response. Just like a paramedic, when you see this heart rhythm, you do this thing. When we see this kind of fire, we do that. We need to have similar procedures for gas leaks. So in terms of size up, it's kind of easy, but it's kind of hard. When you're dispatched to a leak, or odor of gas, whatever it might be, propane, you want to know, is this a major leak or is this a minor leak? Is this life-threatening or is this one of those pain in the ass calls? So that's kind of the first cut. And I'd ask you to think that it's a major leak until you prove it's minor. Now, again, I'm not saying, pull onto the street and start evacuating 300 feet in all directions. I'm saying let's think about this in your size up as it's a major leak until you prove it's not, right? So here's a little graphic. You're dispatched to an odor gas. Is it life-threatening or is it one of those find and fix? Is it major? Is it minor? If it's an underground leak and there's odor gas outside, could be a major event. We all been to the pilot light out, that kind of thing. If the contractor was using a backhoe or excavator and damaged the main, maybe you got gas migrating underground into nearby buildings. If a building blew up, one of the things we need to be thinking about is what caused it and is the next is the next building or one across the street gonna do that as well? Was it just a burner left on? Was it a crack flex line? So you guys get the idea. Is it minor? Is it major? And again, we got to have sequence procedures, and we're going to talk about that in just a minute, based on your gas industry best practices. So again, we talked about this last time. How would you, if you're responding to 186 Main Street here and odor of gas, where would you start? So we want to focus our effort. We want to know where there's no gas. We want to know where there's a little, and we want to know where there's a lot. Again, I don't sell these, but I just think this instrument is so important to the fire service that we all need to have one soon. It's laser-based gas detection. It has a 100-foot range. It gets down to, I believe it's around 10 parts per million. So we'll do very low levels. Just something to think about in the right instruments. It's a pretty hot instrument. There's several manufacturers. These are all basically the same. This is the one we're familiar with. So we showed this video last time. We'll do it again quick here. So the gas was on when I first started that video. I blew the flame out. The instrument, it needs the laser to pass through the gas. The laser reflects off the back surface. The instrument calculates the gas scatters some of the laser energy. So the instrument says, hey, I sent out this much energy. It reads the reflection off the back wall there. It said, I only got back this much, and it does a calculation and tells you how much is there. It works through most glass. For size up, I just think it's an indispensable tool. My department's been using one for about 2 years now, and we love it. In fact, last week we found a leak before the utility company could, and the gas technician was kind of shocked. And another good procedure, a good size up technique is send somebody to the gas meter, the residential or commercial meter, and you can look at this 1/2 foot dial. Back up here. This 1/2 foot dial. If there's gas going into the building, that dial will be spinning pretty quickly. So here's what it looks like. This 1/2 foot dial here. This is my house. I turn the heat on. I turn the hot water heater on. I turn the oven on, and you can see that there's gas going into the house. Doesn't mean that gas is leaking in the house, but certainly there's gas going into the house. We did a call last summer. Woman said she pulled her stove out, was cleaning the stove, broke the flex line in the back, completely off. We thought we had a pretty significant gas leak. I went to the gas meter, saw this meter spinning around, and I asked command. I said, "Can I shut the meter off?" He said, "Yes." So that's a pretty good technique. Obviously, doesn't mean we've solved the entire problem, but kind of step in the right direction. This is a commercial meter, rotary meter. Just you can see it's spinning. It's kind of the same thing. So procedures are, I don't think I've showed you this, our plan A has to work because our plan B isn't very good. This is a gas explosion at about 10%, which is right in the middle for natural gas. The flammable range is 5 to 15. So we're right in the sweet spot here. Let's just take a look at this video. So a lot of good lessons learned there. One of the primary things is the kill box, and we'll talk about that when we talk about procedures. So this is a little tabletop demo that works pretty good. I can give you the specifications for this house. We did fill it with propane. If you do this, remember the propane has a little more energy than natural gas does. When we do this at our fire training center, I use natural gas. We were up at Fort Drum, New York, training their guys, and we didn't have natural gas, so we used propane. The training officer said he wanted to ignite it, so he did, and we burned the hair off his arm. So it's a little more exciting with propane. So let's see if I can get this to go. So this is 5% propane. We used our instruments to make sure we're in the flammable range. So let's talk about some how we train our guys in phases. We introduce the standard operating guideline. We do it on PowerPoint. We do it on tabletop, and we go full scale out to Leak Street. So we're going to go over the first 2 steps of this today. I worked for the U.S. Army for a long while, like 33 years, 10 months, and 8 days, and we wrote policy and procedures routinely. So your SOP should contain 2 parts, I believe: policies, which is a general guidelines and a general kind of boundaries for your officers that are making these decisions, and of course the step-by-step procedures for the boots on the ground. So this is a draft policy I wrote, or draft SOP, and this is just a general policy. So I think the first one is the most important. Life safety is our mission. That just sets the stage. You know, a lot of our firefighters want to go in and fix the leak or find out where the exact leak is. Just reminds them life safety is our job. The kill box, 1 to 2 houses away if it's a residential area, or maybe you want to put in a number of feet or meters there if you're in a city area, you know, an urban area, or half a block or whatever it is. But just set the policy of where you want to keep your guys out of, if we can. You know, we want to limit the amount of people in the kill box. And the kill box is that area around the building that if it goes bang, you're likely to get killed. Again, kind of a fuzzy definition, but you need to give your guys some guidance. Responding units, where do we want our drivers to park? And again, this repeats what's in number 2, but it's so important. Where do we want our guys to park? What do we want them to do then? We don't want to send a whole company in. We want to send in 1 firefighter and 1 officer, maybe just 1 officer. In this case, maybe to the command post or to the building, wherever, however you operate. But let's minimize the people in the kill box. We want to say shutting the gas off at the meter is always an option. It's not something you always want to do, but it's always available to you if you think that's the right thing to do. I talked before about minor and major. We want to assume major until we prove it's minor. For major emergencies, obviously you want to set up a command post. You may want to call EMS for standby. When I got blown up, probably about 15 minutes before the explosion, the chief called for the paramedics to stand by. And my thought was, man, he's really making a big deal of this. It's just a gas leak. And I was really, really glad he did that. Appoint a safety officer if you got manpower to do that. And a situation unit leader, when you start taking gas readings in different buildings, it'd be great to write those down because you're not going to remember them. And if you have to brief your boss, you got a battalion chief or a deputy chief coming in, you can show him a sketch. A whole lot, you know, pictures worth 1,000 words. This is the procedure for my department for locked buildings. Again, you can make that whatever you want for yourself. Action levels in the U.S. There's no minimum or mandatory action level for explosive gases. There is for all the confined space entries and that kind of thing, but just for the routine gas leak, there is no mandatory evacuation level. So 10% LEL is good. Obviously your meter goes off at 10%. Some departments in my area use 20%. I don't care what it is. Some departments use an odor of gas. But again, that's mandatory evacuation. So that's mandatory evacuation for civilians and firefighters. You may want your firefighter evacuation level higher than civilians. That's up to you, but you need to set those policies. Aggressive size up. we don't want to roll up and go, okay, well, we're going to wait an hour for the gas company. No, we didn't roll up with $1 million worth of equipment and all these trained and hot shit firefighters to sit on our thumbs and do nothing. So we want an aggressive size up. And just kind of the basic reminder, don't throw any switches, those kind of things. So that's the general policies. Again, you may want more or less of these, but that sets the boundary. I talked before about the kill box. Again, I showed you these slides last week. This was, I think, London, Ontario, if I remember correct. Right, Rick?
Correct.
So not a happy place to be where the bricks are flying around. So this was the incident, a car into a residential meter, and you can see the devastation here. So how big is your kill box? It's something you need to think about and get it down. This was a Dallas explosion. I believe there's one firefighter in serious condition, maybe more. I don't remember off the top of my head, but it's happening all over. So let's look at procedures, and these are really the strategic and tactical part of it. So this is the SOP I use in class as a draft. It's a checklist, whatever you want to call it. So this is for an outside odor of gas. This is bare bones. This is just a reminder. This doesn't replace training. So this is hey, what do I need to think about when my boots are on the ground? So outside odor of gas, we want to think about it as major because we don't know where this gas is going. If it's coming, for example, from a main or a service line, it could be going into nearby buildings, could be not going anywhere. It could be just coming up and coming out of the ground. So we want to rule out major. So the incident command strategy. So this is 3 or 4 things for the boss to remember. Establish a command post, a safety officer, and a situation unit leader if you're fortunate enough to have that manpower. Estimate the kill box or have your safety officer do that. And again, it's kind of an imaginary circle or square around where you think the leak is and what the hazard is. So determine if gas is migrating underground into nearby buildings. That's the big hazard. And we 44 Controls, our dispatch center, we request the utility to check and see if there's a known leak here. So that kind of sets the stage for the IC. For the tactical actions, okay, so you pull up on your first engine company. What do we want to do? We want to check the buildings closest to the leak source first and evacuate as necessary. So we're going to take our combustible gas indicators into these buildings. Something I would recommend to you is I would first ask the occupant, do you smell gas in your house? And if they say yes, you get a pretty good idea that gas may be leaking into that building. If they say no, you still have to check. But if you ask that question, at least you get that first cut, especially if you have a lot of buildings where this gas may be going into. So you want to check buildings on the 4 sides of the odor site. If it's an apartment building, it's actually 6 above and below. Check the subsurface structures, the sanitary sewers, storm sewers, electric boxes. Don't open electric boxes or manholes, but you can put your 4 gas meter there or your CGI near there. Something you may think about as a tactical action is to open the manholes to provide the path of the least resistance to let this gas out. I put in SOP 25% LEL. If you're getting a higher at that level or a higher gas reading coming out of a subsurface structure, you may want to pop the cap off, pop the cover. People ask me, might you get a spark? Yeah, I guess so, but we want to create a path of the least resistance. So last thing, I just want to walk through a scenario. Here's how we do it on PowerPoint. We give them the information. In this particular scenario, there's a couple of lessons we want to reinforce. If there's a frost layer in the ground, it may prevent the gas from coming up and force it to go further horizontally. Obviously, we want to talk about underground gas migration. That was one of the things that I did not understand. That almost killed me. I had no training in that. I didn't understand it. The gas company may not fix it right. There may be more than one leak. So the gas company, there may be an existing leak there. They don't have to fix it right away. Those leaks are allowed to, as long as they're not going to migrate into the building, it's not uncommon for us to respond to the same location for an underground gas leak repeatedly. So we ask guys, what's your size up? We just talked through this. What's your size of how to protect life? What are the hazards? So here's the scenario. It's 0908, Tuesday morning, 19th of December. So getting kind of cold. Outside odor gas represented by the green cloud. Yes, we sometimes have to remember to tell our firefighters the gas, you will not see the leaking gas. So we talk about size up. So what's your size up? Again, we ask them to think that this could be a major event. It may be minor. We don't know. There's outside odor gas. We want to know where the gas is going. So we talk about what do we know? We know the odor is near building or house number 1 and 2. Again, we talk about minor, major, talk about meters, life safety. Who do we think right now is in the most danger? And it's the general practice is the people closest to the leak. In this case, would be building 2. So those are the folks we want to take care of first. We want to get in that building first if we can. By looking at this photo, you can see there's no overhead electric lines. So we know there's all underground utilities. So all those utilities may be in a common trench, backfilled maybe with sand. So it could be a easy route for a leak out in underground in the street to get back into the building. I'll also remind folks, and I'm surprised so many firefighters don't know this. We all know natural gas doesn't smell. Most of the guys I've trained don't recognize the odorant could be scrubbed out if it moves through the soil. So that's kind of some learning points here. What don't we know? We don't know what is leaking. Is it a main? Is it a service line where it's coming from? Is it migrating or is it just coming up out of the ground? So we asked the fire department where they set up their command post. Where do you stage your apparatus? We go through that. Talk about life safety. So then we give them some air monitoring results. So your first crew goes in and we get 10% right inside the front door of this house. So so what? Well, if your action level is mandatory evacuation at 10%, those people need to come out. If there's gas in the house, maybe you want to get them out anyway. And the other thing is, if you get 10% when you first walk, if you monitor when you first get in the house, in the front door, say, even if you get a 0 reading, we want to go to the basement. It's called the point of entry, where the pipes and the electric service come in the house. Because if this is an underground leak, the POE, the point of entry, is where the most likely place the gas is going to enter this building. So we want to get down there and monitor that as well. So we give them some other readings. We talk about how big the kill box is. We've hit our action levels for 10% LEL, so we're evacuating these people most likely. So we get 80% in the sewer. Again, a trigger maybe to take that sewer manhole cover off. A trigger to remind you that, hey, this gas is in the sewage system. It may be going to all these buildings. Your problem, you're kind of leaning toward major. 50% in the storm drains. Again, if these houses have their sump pumps or their basements or their drainage systems plugged into the municipal storm drainage system, it may be getting back that way. So again, we're leaning more toward major. I just mentioned this. You take your air monitoring right inside the front door, and then your secondary needs to be at the point of entry if there's a basement in that building. So we go through that on the PowerPoint like we did. This is a little leak street. It's just 3. I think I got a better picture. Here's 3 houses on each side of the street. I kept this very simple. The yellow chem tape here toward the center represents the odor of gas. Obviously, we position the rigs and we talk about not being in a kill box and what is the kill box and that kind of thing. The round, these are actually just American dimes. The dimes represent storm drains. These squares represent, the dimes indicate sanitary sewers. The squares indicate storm sewers. In this particular case, this is a training device. This tablet here will send false readings to the sensor, to the gas detector. So guys get to practice with it here, and then we use it again outside on Leak Street. So here's an interesting story. When you roast coffee, it produces carbon monoxide. We routinely, there's a coffee roasting place in my first due area. And we routinely go there and we would chew them out for using the forklifts in the building. And it really wasn't the forklifts producing the CO at all. It was roasting the coffee was producing massive amounts of CO that their ventilation system wasn't taking care of. So Rick, that's what I've got. If we have any discussion or questions, or we'll open it up for that.
Kind of figure my way to unmute everybody and see comments or questions, guys, gals. Somebody's got a story somewhere.
He's a fire guys and gals.
I'm going to pose a question to you. We've had a couple of times in Toronto where guys have gone to shut off a gas meter and they literally broken the valve. It just does a quarter turn and it pops out, and now we've got high pressure coming out the front of the house. Has anybody else hit any sort of problems with maintenance on gas meter valves? You come across it before, Jerry, or had to deal with one? Or
we have a department near me did just that probably a year ago now. We teach our guys to use a Halligan tool, which you can get, Rick, as you know, you get a lot of leverage. We've since changed that to use a regular crescent wrench. It's a little less chance that Mungo is going to break it,
Yeah, I think part of it is just getting guys to understand that how to put not a lot of maintenance done on those units, and certainly up here with the weather that we've got and so on. I imagine north in US similar in that they just get old and kind of just aren't working. And of course, when it doesn't move the first time, you try harder, and then third time around, it's like I said, it's out in the street, and it's like, okay, now made good in that there's nothing leaking in the house anymore, but we've got a whole lot more pressure and a lot more volume coming out in the street now, so it becomes a bit of a different challenge. So
yeah, because you're breaking it off before the regulator, so you've got street pressure.
Yep.
We're in the 60 to 90 psi range. I don't know what you guys are.
I think we're about the same, depending on delivery and stuff. But yeah, I'm gonna say we're probably at 60 at minimum, I would bet.
Yeah.
But
So,
you made a comment at one. Oh, sorry, Dave, you had something there?
Oh, I just want to just add where I work. Well, where I work. We've gone through some big changes at the top management side. So we're in the process of looking over policies and procedures. And I had a quick look at our natural gas procedure, because sometimes we go around the table here and put each other on the spot to see if we know what our policies and procedures are.
good for you.
And looking at ours right now, real quick, I can see the last time it was updated was 2013, and it's 3 pages, and it speaks to everything. I came late, so I apologize, but from what I caught from your discussion so far with your kill zones or kill box, stuff like that, our policy speaks to that, but at no specific numbers. It just says be safe. It's open for some interpretation. However, I do like the fact that we as this group we're having these links on our website. So I am going to point our health and safety guys towards these 2 presentations and see. It's not an everyday call for us where we are, but we run a lot of those calls. So I think that might be one of our policies that we can look at. They've gotten hard and heavy in the high-rise policies and stuff right now, but I think with this one being so old and vague, I myself will push our health and safety guys to perhaps have a look at this policy.
Yep, no, sounds good. Sounds good. And the fact that it was 2013, I'm hoping there was at least a couple of looks at it since then, because otherwise Big Brother comes and looks and doesn't see it was reviewed, not necessarily revised, but if it wasn't reviewed in the last 8 years, that's a slam coming at some point. I'm going to suggest, and I think it does become that issue as we try and get more information and share it. How do we get it into policy, or how do we get it out there on the streets? I agree with what Jerry said earlier on. Training on metering is woefully inadequate to start with, and then on natural gas in specific, I guess I have a bit of a concern. I don't want to show up in a natural gas call and everything's a big bad thing. And I think it is very much that risk-based response, or the approach. And the idea is that, we can start to do some queries about odor from people around. I love the idea of a meter coming off the truck, etc. More often than not, I know if I'm 20 minutes late showing up with a heavy haz truck, it's basically to tell the chief quit evacuating, full blocks away. Trying again, lack of training and so on. So it's like, no, let's see, it's a post hole out in the back of a backyard going straight up into the air. We don't need to do a whole bunch of this stuff. But again, reflection of the lack of training. So I was going to just kind of speak to an issue you talked about, the conduits or the piping, all piping coming into a basement and so on. I remember, it seems like 100 years ago now, but we had a repeat call into a house for an odor of gas. And probably, I guess we were on 4-day shifts. So I was visiting that place every day and finding nothing. Day 4, finally got into a little bit more investigation, and basically no natural gas in the building at all, but there was an odor there, and ended up just above the meter where the conduit or just above the fuse box, I should say, where the conduit comes through the wall. Got the teeniest little tickle right there at the box. And turns out we actually had a break in the line out in the street under the sidewalk. And it just simply, as you said, finds the path of least resistance. So it walked along the outside of this underground conduit and basically come in through a fuse box.
Wow.
So
that's a great story.
Well, like I said, just, it does amaze me that, like I said, you kind of discount and go, you can't have natural gas odors in a house that doesn't have natural gas. Oh, yes, you can. And again, it's understanding just that how easy it does migrate through the ground. And like I said, it finds a way in. And sure enough, they tore up the sidewalk and found a couple of leaks out there on the street level. So
Rick, did you go there because the occupant was reporting a gas leak or odor?
Odor. She was getting the odd odor and a little bit of a headache towards the end of the day. But, you walk through, people open up the doors, you can't smell anything,
Sure.
People are in at lunch and out again and stuff like that. Yeah. So nobody was actually smelling it. I don't recall smelling it while we were there, but, she was complaining and we're trying to take care of things. And like I said, it was a long reach. It was four days that we visited. And on the 4th day, like I said, finally come up with that little hit, got the gas company in, and sure enough, it's out at the street level. So, but yeah.
So I think there's some really interesting points there. Most humans can smell natural gas at less than 1 part per million, or I should say smell the odorant, right? They can smell odorant less than 1 part per million. Our meters, if you're using a catalytic bead-based sensor, it's not going to pick it up at least until 500 parts per million. So you can go into this house and be smelling natural gas, or into this building and be smelling natural gas, and your meter's going, no, I'm not seeing anything. Well, in the hazmat world, we all know that lower level of detection is important. Everybody thinks the meter is going to find it, down to 1 part per million. And with our catalytic bead sensors, that's not true. And actually, a lot of them, there's built-in software, so it doesn't register even like to 1% LEL, so you don't get false alarms. So understand there's a blind spot below whatever you want to say, 1, 2, 3% LEL for your catalytic bead sensors. And I did not understand why. It took me a long time. The fire department in New York had their 4-gas with a cat bead sensor in it, and they would bring a metal oxide sensor in as well. And I never got it because I say, the damn metal oxide, it doesn't tell me anything. I want to see a number, but that's seeing the gas a lot lower, like down to 10 parts per million than the cat bead is,
Yeah. And I think, again, that becomes something where, again, the training needs to happen. I'm going to say, I think every fire department should have, go visit the local HVAC supplier and find out what leak detectors they're buying for both natural gas and refrigerants. Simply add them to the inventory. It's not a big purchase, but just in terms of getting those little nuisance numbers is a big plus for it. So
that laser detector too, I think it's a great instrument. That'll get down to about 10 parts per million. So over a long distance gives you pretty good sensing capability. So
yeah, I know. I think last week there, I guess Tom was talking. I guess Mississauga Fire had bought one, and I'd heard, and the price tag of around 12 grand or something, I think was a conversation last week. So anyhow, I just need to keep reaching out to Justin out there and just see, if do a drive-by and visit sort of thing, but and see where they're at with things. So,
Nice.
but
Any oth-
the other
any
one I
other-
wanted to make mention of, I had an event at one point with natural gas. Basically, they're doing I guess a row housing, so all connected together. But in the middle unit, they're doing a demo inside, and basically this guy is cutting with a sawzall, with a reciprocal saw, through the crown molding. He got halfway through a piece of 1/2-inch black pipe before he stopped.
Ooh.
So there was some big numbers coming into the house in a hurry. One of the things I found curious was we went to operate the valve, and the valve wouldn't operate, and turned out it was a neighbor a few doors down, worked for the gas company. He says, I can't do this officially, but watch this. And he simply broke the union on the low pressure side going into the house. He says, now you've got a leak outside instead of a leak inside. And I'm going, you know what, in terms of changing the risk aspect, that was a rather, a smart move. I was very impressed with it. Like I said, instead of a 1/2-inch black pipe inside just leaking full on, now you've got a leak out the front of the house, which we can manage a little bit better than launching the house. So,
and if it's on the downhill side of the regulator, you're down to what is it, 1/4 of a PSI, or
yeah.
I mean, it's minimal. Outside, that's nothing,
Well, and that was it. It's just, let's change that environment. So yeah, 1/4 PSI, and it's hissing outside now. We can control that with a fan, just to keep it away from the house, let it go up in the air. Life is good. Versus the leaking full on into the basement was we're waiting to launch that place. So yeah.
Well, great story, Rick. That's another great experience-based story. Super.
And again, it becomes that idea of, just like yourself, sharing the stories, and that way, we're all a little bit safer next time we go out on the call. And then certainly, we'll continue. Certainly, all the departments that are listening, or the people that are listening, I'm sure that will, get back and get around. So, all right. Anybody else story time or anything else to go, or anything you want to add, Jerry?
I just, if anybody has any good war stories or questions or comments, that'd be great. Be great to hear from you.
I think they've all gone shy on us, Jerry.
Yeah, we muted them all. And said, so I'll ask a question. Is this useful to you guys, or are we wasting an hour of your life here?
Oh.
If I got to hear the whole thing, we had to run out for a call, but from the little bit that I did hear, it is helpful, especially the war stories.
Yeah, I think the experience that you guys share is good. There is a webcast up on Fire Engineering's website. It goes about an hour. If you missed part of this, that and more is on there. So it's on Fire Engineering's website. I think you can search my name or whatever, but it'll come up.
Yeah.
So.
Yeah, thumbs up there from Tyler. Yeah, lots of good info. So he's indicating certainly the benefit, and yeah, like I said, this was being recorded. It will also go onto our website on the member side. So both last week and this week, any of our members will be able to kind of revisit it and get caught up on any of the missing details. So
good. And just to kind of wrap it up, this course came from in 2012. I got blown up in a natural gas explosion. It was only the grace of God that I'm alive. And my captain was out of work 13 months. I was out of work 6 weeks with injuries, burns, and fractures and those kind of stuff. And thank God we got over that. But it came from, I didn't know what I didn't know. I thought I knew all this stuff. And I just, Rick, from you learning about breaking the union, never heard of that before. So guess what? That'll be added in. So
we keep on sharing, and like I said, it's the whole idea of just sharing it. Knowledge is not power. Knowledge is good when we can share it. So the minute we can get it out to everybody, it's going to work out a little bit better for us. So absolutely. All righty. Well, having said that, I'm going to kill the recording on this. I do thank you, Jerry, for your time, and again, we can always stay in touch. I mean, any stories or any communication, by all means, get hold of myself or Steve or whatever, and we'll keep the doors open. So anybody wants to email me, Rick and Steve have my email. It's J for Jerry, my last name, Knapp, Knapp 23 at AOL. Call me, email me. This is kind of a passion. So please, we'll stay in touch. shows very well. Thank you very much, Jerry.
All right, guys, thanks.
All right, bye, everybody.
Yeah, see you all.